Okay, sixth grade, our objective today is to talk about area and perimeter of about 5 different figures. So we're going to get to that here in a couple minutes. Let's start with going over the warm-up. So let's start with, this was page 4 of your notes, number 7 and 11. Evan? Okay, all right, Evan, number 7, I want you to first tell us, how did you set this up? Yep. Good. And Evan, why did you set it equal to 360? Awesome. So there's 360 degrees in a quadrilateral, so add up all of the interior angles, set it equal to 360. Evan, what did you get for x? Awesome. After you combine like terms and solve for x, you guys all should have gotten x was 2, so hopefully you tried the warm-up. One question that kind of goes off of this is, what is the formula for any polygon to find the sum of interior angles? I'm going to ask you this every day. Neil? Nope. The sum of interior angles. David? Good. N minus 2 times 180. What is the sum of exterior angles of any polygon? Grace? Good. 360. Again, you will see that again in Chapter 8 of Geometry, so keep that in mind. Okay, number 11, the very first step of this one is take 2x minus 1 plus 3x minus 32 plus 2x plus 13 plus 3x, all equal to 360. Josh, what did you get for this one? Say that again? Nope. Off a little. Camille? Good. You should get x is 38 on this one. After you combine like terms, maybe some of you guys combine like terms wrong, you get 10x minus 20 equals 360. And then add 20 to both sides, you get 10x equals 380. Divide by 10, you get 38. Okay, those of you that did your warm-up, any questions on either one of those? I'm assuming this is pretty easy, right? Okay, Ben? Okay, you might have left it at school or somewhere else. Don't worry about that right now. Okay, let's go to the homework. If I could get there. All right, so page 518 in your book. What questions do you have for me on this besides 24 for now? Because I know a lot of you probably need me to do 24. I will. So for now, besides 24, Peyton, what number? 14 and 16. Okay, 14, the question is, a square is blank a rectangle. So a square is always a rectangle. Because you can always say that a square is a rectangle, because it always has sides congruent, opposite sides parallel, and 4 right angles. So a square is always a rectangle. 16 says a rhombus is blank a square. So 16 is a rhombus is sometimes a square, because we know a rhombus always has congruent sides, but what do we not always know about a rhombus? Jackie? Yeah, we cannot assume that a rhombus always has right angles. It might sometimes, but we cannot assume that based on the definition of a rhombus. Does that make sense? Anyone else besides 24? Positive? Steve? 6? You got 42. You probably just, I'm guessing you just solved it wrong, but you guys got 42? Okay, it's 43, but I'll show you. Okay, number 6, let me try to draw this. It looks like this. This is y degrees. This is 2y minus 3 degrees. This is 97 degrees, and this is 137 degrees. So you need to add everything up and set it equal to 360. So the first step should be 137 plus y plus 97 plus 2y minus 3 equals 360. So combine like terms, we get 231 plus 3y equals 360. Subtract 231 from both sides. We get 3y equals 129. So Steve, check yours to see if you got that. Divide by 3, and that's how you get y is 43, not 42. Okay, guys, all of you that got it wrong, look back at my work. Okay, listen. First step, check to make sure your work looks like mine. And then combining like terms, adding up 137, 197, and then subtracting 3, you get 231. And then the y's, you have 1y plus 2y, which is 3y. You probably combined something wrong, is what I'm guessing. Nathan S. No, you forgot about this minus 3. What did you get for your answer? Okay, so that's why. So maybe some of you guys forgot the 2y minus 3, the minus 3 part of it. Abigail, did you find your mistake? Okay, but it shouldn't be 234, it should be 231. Okay. Subtract the 3, you mean? Okay. Anyone else before I get to 24? Abigail? You sure? I thought that was a hand. All right, so 24, which was a challenge problem, but I figured you guys could try it. Raise your hand if you got that one right. Just curious. 24. 24. Okay. All right, so here's what it looks like. See if I can do this. I am not good at drawing, so we're going to use our imagination here. Here's what they give us. Thanks, Neil. I appreciate that. It makes me feel a little better. $60. This is 45. Okay, that's all they gave us. So based on the figure, that's everything they gave us, okay? We need to find, so you guys remember, the measurement of angle WXY and the measurement of angle XYZ. So if you didn't get this right, make sure you're paying attention. I would say one of the first things that I would do is find this angle. How can we find this angle right here that I'm pointing to? Amberly, how can we find that? Yeah, why? How do you know that's 45? Yeah. So in this triangle right here, we already have 45 degrees and we already have 90 degrees. Steve, you're with me, right? So you need to find, okay, what's missing? If there's 180 degrees in a triangle, we're missing 45 degrees. So that's what you're missing in this triangle. This angle right here, this angle right here, this angle right here, and this one, these all are 90 degrees. All of them. There is a theorem that you guys will learn when you go to geometry, but basically, if this side is a right angle, this side has to be. This is called a linear angle pair. You don't need to know that now, but these have to be right angles. If this one is, this one has to be. This is a straight line. These two have to add up to 180. You could also call it a straight angle. Okay, and then what about this one? If we know this triangle over here, we know this is 90, this is 60. Josh, what does this have to be? Good, it has to be 30 degrees. So that's all you needed. Now to find WXYZ, WXY is right here. So all you're doing is taking 90 plus 45 degrees. So WXY is 135 degrees. And then the other one was XYZ. So XYZ right here. You're taking 90 plus 30. And we end up with 120 degrees. Steve, does that make sense? Because this is 45, this is 45, and this is 90. There's 180 degrees in the triangle. This right here is 90 degrees. This is a rectangle in here. This is a triangle. This is a triangle. Greta? Because these two are congruent, and if these two are 90, these two are going to be 90, because these two are congruent. So in other words, these add up to 180. So if you take 360 minus 180 and divide by 2, you get 90. There's nothing else these can be because they told us in the book that these two angles were congruent. That's a good question. Does that make sense? Neil? Okay. Anyone else? Anything on the homework? Okay, so do you think this chapter is easy so far? Yep. Okay. All right. What'd you say? That's a good bonus, something like that. You guys can get it eventually if you are still a little confused. What I want you to do is look at it again tonight or at some point on your own. If you can't figure it out, please let me know tomorrow and I'll go over it with you again. Okay, I need you guys to open up, I think it's your notes, let me make sure. No, homework packet to page 152, and then we're going to go back to the notes. So homework packet, let me make sure this is right, to 152, yep. And then we're going to go back to the note packet. So here's something, shh. Guys, here's something that I wanted to do yesterday, but we did not have time. So in your homework packet, page 152 is where we are. Homework packet, page 152, and then we're going to go back to the notes for a little bit. Okay, so this is a quadrilateral flow chart. So at the very top of the flow chart is a quadrilateral. The very top of the quadrilateral flow chart is a quadrilateral. So on page 152 in the homework packet, GO 152. Okay, very, very top. What do you guys think? If that's a quadrilateral, what do you think this is? David? Good, parallelogram. So I'm going to take over the parallelogram, and there we go. There's our parallelogram. If that's a parallelogram, what do you think this is? Grace? Good, rectangle. Guys, raise your hands, please. Okay, if that's a rectangle, what do you think this is? Camille? Good, rhombus. Okay, and what about the one on the very bottom, Drew? Good, square. So let me explain that real quick. Looking at the top is a quadrilateral, Steve, 152. All of these figures are quadrilaterals. So all of these figures are quadrilaterals. Okay? A square is a rectangle, a square is a rhombus, but a rhombus is not always a square, a rectangle is not always a square. Parallelogram, falling underneath it, all three of these are types of parallelograms because opposite sides are parallel, always. What do you think this is? Abigail? Good, kite. And last one, we're going to talk about today a lot more, trapezoid. So a kite and a trapezoid kind of fit in. We're going to see more today how and why they fit in the way they do. But just looking at what we have, so a trapezoid and a kite are both types of quadrilaterals. A kite is related to a rhombus, but not anything else. Why are kite and trapezoid not under parallelogram? Why are they not under parallelogram, Drew? Good. They do not have opposite sides or parallel. So that's one of the biggest reasons that they do not fit under the branch of parallelogram. Okay? Any questions on the quadrilateral flow chart? This is something that you can go back to that we will relate to. Okay, flip over to the polygon chart. So this one's kind of cool. So right at the on the back of that is the polygon flow chart. Today we are going to talk about circles. So if I can find my circle. So go ahead and write circle in the circle. So today we're going to talk about circles. This little thing that's squiggly right here should be closed figure. So all that means is a polygon has to be a closed figure. I'm just going to get it started for you guys. Thank you, Nolan. Did you do better? Okay, thank you. Okay, the one more I'm going to give you, then you guys are going to fill in the rest, is polygon goes right here. So a polygon, of course, a circle is not a polygon, but we know polygons are closed figures. They have to have segments. They only intersect at the endpoints. No curvy lines. It's a closed figure. Okay, let's start here. What are we going to call this? Good, triangle. So go ahead and fill in triangle for the one at the bottom. There's our 3 sides. Okay, Steve, what do we call something with 4 sides? Good, quadrilateral. Hi, how are you? Good. Math good? Good job, Brittany. All right, so there's quadrilateral. How about something with 5 sides? Alexis. Good, pentagon. So this is kind of like what we did yesterday, but it's actually in a flow chart. Okay, how about something that has 6 sides? Abigail. Good, hexagon. Okay, how about something that has 7 sides? Amberly. Good, heptagon. And I wrote on there septagon, heptagon, because last year some people used the word septagon instead of heptagon. Either one is fine with me. Okay, what about above that? This is supposed to be 8 sides. It doesn't look very nice, but Grace? Good, octagon. Okay, this one has 9 sides. This fancy little arrow. Evan? Good, nonagon. And what about the nice star? Amberly? Okay, what if I had something on here that had 12 sides? What would you call that? Kevin? Good, dodecagon. Anything with 11 sides or more than 12, what do we call that? Nathan S? Good, an n-gon. So anything with 11 sides or more than 12, we're calling an n-gon. So the polygon flow chart, all this reminds you of is how to name figures with 3 through 12 sides minus the one with 11 sides. A polygon, all these branch off. The only thing that points to this is closed figure. Okay, a circle is not considered a polygon. We will talk more about that today, but it is a closed figure. Okay, this is something if you need to practice the names of your figures, this is something good to go to. Any questions on that? Okay, let's go back to our notes. And I think it's page 5 in your note packet, lesson 10.3. It is very easy, very easy. That's why I'm moving kind of fast in this chapter, because compared to everything else we've done this year, this chapter is really not that bad, but it's really good for geometry. Good preparation. Okay, so 10.3, is it page 5 in your notes? Yeah. Okay, good. Mine is 6, yours is 5. Okay, so as you can see, we are going to talk for about 15 or 20 minutes about area and perimeter of rectangles, squares, and triangles. We've already done this year. So we're going to go over the formulas. We're probably just going to do 2 or 3 examples and then talk about the trapezoids, parallelograms, and that's all. So 5 figures that we're going to talk about. Okay, skip the definitions. We're going to go right to the box that says area of a rectangle. So really, you guys should all be able to fill this in without me giving it to you. What's the formula for area of a rectangle? Kevin? Good. So real big, I want everyone to write down. Area equals length times width. We didn't get there yet. Okay, Ray, area of a square. What do we usually put, though? Jackie? Yeah, side times side, and really, Ray, it doesn't matter. You can put length times width, but since a square has all sides same, typically it's nice to use the same letter, okay? But again, if you put L times W, you're fine. You'll still solve it correctly. Okay, and then a triangle, Drew. Just base. Good. Base times height divided by 2. I usually say 1/2 base times height, but base times height divided by 2 is fine. I know a lot of you guys prefer that. So why do I have these pictures here? There are 3 pictures at the bottom because sometimes they'll give you a triangle that may look like this. Here's the base, this whole bottom part. Here's the height. You might get a triangle that looks like this. Here's the height, here's the base. Yep, lastly, this one's kind of weird. Look, what I'm drawing in blue, this is the actual triangle. They're giving you the height from here to here. If there's a dotted line, this is not part of the triangle. It's just telling you how tall the triangle is. So this dotted line is not part of the triangle. It's just telling you how tall it is. So keep that in mind, please. The base is only right here. Don't let that confuse you. There are some problems like that in your homework, so be careful. Gio? No. The height is from the bottom to the very top. It's not the hypotenuse, Gio. The height of a triangle is from the bottom to the very top. It's a straight line. From here to here is the height. You're measuring it. It's a vertical line. It has to be perpendicular to the base. So it's not slanted. You're not slanting a line to find the height. It's kind of like if you stood like this, would we measure you like this to see how tall you are? No. You're going to see how tall you are from, your feet to the very top of your head, not if you're standing like this. You know what I mean? Okay. Anyone else have questions on those? All right, so let's flip over to the next page of your notes. We're going to do a couple examples. They're kind of hard to see on my board, so I'm going to shut this light off for a little bit. Is that okay for a little bit?
Keep it off.
Yeah, just no one get sleepy on me, please. All right, so we are going to find area and perimeter, which was not part of the formula. Just remember, to find perimeter of any of these, we're just adding all the sides up. So let's find area of the first figure. So my first question to you is, what kind of shape is that? What kind of polygon, Nathan? Good, this is a rectangle. So I'm going to write above it rectangle. We are using the area formula of length times width. So this is why I told you to have your calculators. Instead of multiplying decimals by hand, you're more than welcome to use your calculator. So all we're doing is taking 8 times 5.5 centimeters. What is the area of the rectangle, Kevin?
44 centimeters squared.
Good job. Please do not forget units. Just like Kevin said, area is always units squared. Always. Okay. How do we find perimeter if they only gave us 2 sides? Nathan S. Good job. So for a rectangle, we did this earlier in the year. Take 2 times length plus 2 times width. You may also take 8 plus 8 plus 5.5 plus 5.5. Either way, when you add all of those up, what is the perimeter? Jordan? Good. Perimeter is 27 centimeters. Questions on that one? Okay, let's go to letter C. So let's jump to letter C. Okay, letter C, what kind of figure is that? So what's the best classification? Peyton? Good. This one is a square, as is letter B, but we're skipping letter B. So we're going to find the area, which is side squared, side times side. So we have a mixed number, which is 7 1/3. So we have 7 1/3 squared, which is the same thing as 7 1/3 times 7 1/3. I would change it to an improper fraction. What would be the improper fraction of that mixed number? Abigail? Good. I would type in your calculator, if you want to do it on the calculator, in parentheses 22 divided by 3, and then square it. So either as a fraction or as a decimal, I'll write down both of them. Josh, what'd you get? Good. 53.8, what kind of inches, Josh? Good. Inches squared. Ooh, didn't mean to go that far. Okay, so 53.8 inches squared. You may also leave it as an improper fraction or a mixed number. That's up to you. Kevin? Yes. Yes, that's how I left mine. If you leave it as 53.777, whatever you put, something like that, that's fine. Evan? That's fine. That's fine. Okay, perimeter. How do we find perimeter of this square? Michelle, what would we do? How would we find perimeter? Good. 7 1/3 times 3. And again, you may also, thank you. I don't know why I just said 3. Times 4. Thank you. You may also change it to be 22 over 3 times 4. So also write that down. Either way is fine. Regardless of which way you multiply, what is the perimeter? This one will be a decimal as well. Joseph, did you get it? What'd you get? Say that again. I can't hear you. Not 9 1/3. You said 9 1/3? Okay. Peyton? No. David? Yeah, it should be 29 1/3. And that is just inches. Make sure, if you guys did this on your calculator, that you took 7.33333, type in as many threes as you can, times 4, or do 22 over 3 times 4. If you do it by hand, you can do 22 over 3 times 4 over 1. And if you leave it as an improper fraction, that's fine as well. Steve? No, you could do 29.3 repeating. Jordan, you okay? I didn't know if that was your hand. Questions on those two? Okay, let's do 2 more. Let's go to letter F, and then we'll do one more after that. Okay, letter F, so we have a triangle here. It has a height of 2 and a base of 1.5. So let's find the area first. Perimeter is going to be a little tricky on this, but let's find area first. So for letter F, we have base times height. Base is 1.5, height is 2. So we should multiply those first and then divide by 2. So base times height divided by 2. Tiger, in the yellow folder back there, you'll see 2 quizzes sticking up. I would start with the elimination one. Okay. Okay, what is the area? Kevin?
1.5 meters.
Good. So we end up getting 1.5 or 3 over 2 meters squared. 2 times 1.5 is 3. 3 over 2 is 1.5. Again, you may leave it like that if you want. Okay, now, how do you find perimeter? Kevin? Good job. We need to use Pythagorean theorem, your favorite thing, and we need to find the hypotenuse. So sometimes you'll have to go back to Pythagorean theorem, which is a squared plus b squared equals c squared. So let's find c. So we have 2 squared plus 1.5 squared equals c squared. We have 4 plus 2.25 equals c squared. We end up with c squared equals 6.25. Square root both sides. Yes, we are going to change this to a decimal so that we can find the perimeter. So Amberly, what do we get? That's the whole perimeter. What did you get for your hypotenuse? You're ahead of us. Make sure you're writing all this down. Yep, 2.5. So we found the hypotenuse is 2.5, which is what we need to find perimeter. So that's our C. And our perimeter is 2 plus 1.5 plus 2.5. Amberly, what'd you get? And you guys, if you're ahead of me, you all should have gotten 6 for the perimeter. Questions on that one? Okay, one more. Let's go to letter H. Okay, letter H is the one that Gio was asking about. They give you the base, they give you the height, but the dotted line has nothing to do with the actual figure. So we have area equals base times height divided by 2. So all you're doing is taking 8 times 7 and then dividing by 2. This is the height of the triangle. The dotted line has nothing to do with the figure. The 8 is the base, which is just the solid line. So what is the area of that triangle? Nathan? You said 28? Good. 28, and what kind of inches, Nathan? Good. 28 inches squared. We're not going to find perimeter on that one. Don't worry about that one. Questions on how you get the area on that, Neil? In geometry, you will. Yep. Kevin? Yeah. If they give you some of the sides as decimals, keep it as a decimal. If the sides are nice numbers, I prefer that you keep it as a radical. Yep, and I'll clarify that when we get to the homework as well as on a test. Josh. On this one, we're not finding it on this one. This is something that you'll do in geometry because this triangle is not a right triangle. So we only have this side. That's something that you'll do in geometry, so that's why we didn't do it on that one. Okay, Josh? Okay, let's go to 10.3b in your notes. And we're going to jump to the formulas. 2 more formulas that we're going to practice, and then we're done. So do you guys remember how to find area of a parallelogram? Kevin, you remember? Yep. Area of a parallelogram is just base times height. It's very similar to a rectangle. Here's an example of a parallelogram. Here's the base. Here's the height. So here's the base. Here's the height. Here's another example. Here's the base. Here's the height. Here's another example. Base, and then if they give you a parallelogram like this, just like with the triangles, this dotted line is the height, not part of the figure. Okay? All right, trapezoid. Anyone remember this? Gio, you remember? No. Camille? Yes, good job. Base 1 plus base 2 times the height divided by 2. Base 1 plus base 2 divided by the height, times the height divided by 2. This is similar to area of a triangle, but the biggest difference is, and I'm going to draw a picture, if this is our trapezoid that we're finding area to, this is base 1, this is base 2, this is the height. So similar to a triangle, but of course there's 2 bases. You'll see the formula on standardized test as 1/2 times height times base 1 plus base 2. But I'm going to keep it as divided by 2 since most of you prefer the triangle formula as base times height divided by 2. True? Yep. Base 2 is from here to here. Base 1 is from here to here. Yep. Okay, so let's do 2 or 3 examples here. Let's flip over and we're going to do the first one. Okay, and we're just finding the area of these. So what kind of figure is the first one? What is that? Greta? Good, parallelogram. Evan, how do we find area of a parallelogram? Good. So we have area equals base times height. So all we're doing is taking the base times the height. So 18 times 6, base times height. It's a 6. Your copy is just bad, I promise. Mine is a lot lighter. It's a 6, I promise. It's a 6. The copy is bad on yours. So 18 times 6. So what's the area? Kevin?
108 inches squared.
Good, 108 inches squared. That's for our parallelogram. Neil? Yes, yes. Probably half a point off. Gio. Okay, second one. What kind of figure is that? Peyton? Good, trapezoid. So I'm going to write down trapezoid. And to find the area of a trapezoid, we have base 1 plus base 2 times the height, all divided by 2. So we have area equals base 1 and base 2, Drew, please listen, are 8 and 18. The height of this one is 12, and then divide by 2. So there are many ways to solve this. Of course, we all have to add the bases first. So we have area equals 26, I'm going to keep that in parentheses, times 12 divided by 2. And if you multiply them first, you get 312 over 2. You may also divide one of them first by 2, but it might be safer. Multiply these and then divide by 2. So what is the area of the trapezoid, Amberly? Good, 156 feet squared. So let me say that again. Add the bases first, and then multiply by the height, and then divide by 2. It's probably the safest way so you guys don't make a silly mistake with that. Okay, I want you to try number 3. And I think we might just do one more after that. So try number 3. Did you do 312 divided by 2? You should be writing down all your steps. Remember I told you that? You're not doing that. Everything I write down is there you need to write down. So if you go back to study from this, you know where you're getting things from. Okay? Erase that and redo that one. I know, erase that, and I want you to follow those steps. Yeah? That's what I said, yeah. Did you guys get the answer? Okay. Here, Shima. Yeah, go ahead. Good. Awesome. Drew and Ray, enough with the talking, okay? Good. Good. Awesome. All right, number 3, I'm going to try to squeeze it in here. We have area equals 5 plus 7, base 1 plus base 2, times the height, which is 2, divide by 2. You guys, after you add, multiply by 2, and then divide by 2, end up getting 12 meters squared for the area. Any questions on how to get that? Okay, let's go to give me a second here. Let's go to letter C at the closing. So closing letter C. This is probably as difficult as these will get. So letter C at the closing. So this is different because you're given the area of the trapezoid, but we now need to find base 2. So this reminds me of those compound interest problems where you guys would have to find R or find T. So letter C on the closing, we need to set this up as 475, which is the area, is equal to base 1 plus base 2, which we do not know, times height divided by 2. Okay, there's a couple ways that we can do this. So, Gio? Okay, that I wouldn't do it that. You can do it that way, but that's more work. There's 2 things I'm thinking of that will be a little bit faster, Gio. Josh, what do you think? Okay, what'd you get? No. Joseph? Okay, we could multiply both sides by 2. What's another thing we could do? And that's perfectly fine. If you guys want to do it that way, go ahead. Nathan? Did you have another idea? On both sides? Okay, Gio? Yeah, so you could either multiply both sides by 2, or you could divide the 25 by 2 to get rid of it. Whatever you prefer. Okay, if you like multiplying both sides by 2, go ahead and do that. I'm going to divide this by 2 and do it that way. So we have 475 equals 25 divided by 2 is 12.5. And we're left with 17 plus base 2. Don't do that. You're going to confuse yourself doing it that way. Kevin. Not yet. So at this point, we need to get this B2 by itself. How can we get rid of the 12.5? Peyton? Good. If we divide both sides by 12.5, we'll get rid of it because 12.5 divided by 12.5 is 1. Drew? You're fine. Go ahead and keep doing it. You mean multiplying both sides by 2? Multiply this side by 2 and multiply this side by 2. After you do that, you're going to divide by 25 and then subtract by 17. You should get the same answer as me. So 38 equals 17 plus B2. That's after we divide. So no matter what way that you solve this, Joseph, did you do it the other way? What did you get? Yep, you got it. So in anyone, no matter what way you do this, you should get that base 2 is 21. Jordan, you okay? Josh? The area? Oh, yeah, okay. Yeah, keep going. You divide it by 25 first, okay? Okay. That's fine. And then subtract 17. That's fine. But last time you said you got 2. Did you get 21? Okay. Yeah, that works too. There are about 5 different ways to solve this. Pick whichever way you guys are more comfortable with. Okay, thumbs up, thumbs middle, thumbs down on area of the 5 figures we talked about today. Okay, homework packet, open up to 10-3, please. We have a couple minutes. Sorry, I wanted to give you more time, but we at least have a couple minutes. And on 10-3, I think I want you to do all of them, but let me make sure. Yeah, there's only 15 questions. Yeah, I want you guys to go ahead and do all of that. We just did finish lesson 10.3, Ray. We didn't do 10.1 either. We did it in the book. Sometimes I'll switch it and we'll do book work. The reason I had you guys do homework in the book for 10.1 and 10.2 is your note packet had some problems repeated that were in the homework packet. So, all right, so go ahead and get started. If you need to write down any of the area formulas, go ahead and do that. 14 and 15 are going to be a little bit harder, but you should be okay. Okay, show your work. Okay, that way if you make a mistake, we can figure out what you did wrong. You guys have about, we'll stay for about 3 or 4 minutes to do this.